Hello and welcome. This is the third video in our series for the SAT Practice Test 2, the calculator section. We're going to be doing questions 11 to 15 here. If you like these videos, if you learned something, please like and subscribe, and let's get it started. So we're here at question number 11, and we're told that Tony is planning to read a novel. Table above shows information about the novel, Tony's reading speed, and the amount of time he spends to reading the novel each day. If Tony reads at the rates given in the table, which of the following is closest to the number of days it would take Tony to read the entire novel? See, part of the problem here is when we look at this, we have 6 different pieces of information, and it doesn't seem like we're going to be using all this information. Now let's see what we can do though. We can categorize the information they're giving us by what type of information it is. So we only have one measurement for a time, and that's the first one, the number of hours. We only have one measurement for a rate, which is the number of words Tony reads per minute. Everything else is a measure of just raw data of the book. Let's see what we can do with that. Well, we know that we have one measurement of time and one measurement of rate, and we need a measurement of like distance, say, right? Because distance equals rate times time. Now, the measurement that goes with this is the number of words. Since we know that we have 250 words per minute, and now we can use words because we have no other conversion factor between words or pages or parts or chapters. So we can say 349,168 words, and then we can use this strategy called factor label, which is basically where you multiply something by a bunch of ones, right? Where the one, like say this factor, the second factor, 1 minute over 250 words, that is equal to 1. Because 1 minute is equal to 250 words per minute. So this is technically just multiplying it by a 1, but it helps cancel out the units. The same thing we can do 1 hour per 60 minutes, that's 1. 1 day he spends 3 hours reading, and that will give us 7.7 days when we multiply this out. That's closest to 8 days, which is answer choice B. Let's keep going. On January 1st, 2000, there were 175,000 tons of trash in a landfill that had a capacity of 325,000 tons. Each year since then, the amount of trash in the landfill has increased by 7,500 tons. If Y represents the time, in years, after January 1st, 2000, which of the following inequalities describes a set of years where the landfill is at or above the capacity? Alright, so we start with 175,000 tons of trash, right? It has a capacity of 325,000 tons total. So if we wanted to write an equation for the amount of tons of trash in years after 2000, we would start at 175,000, and then we would add 7,500 tons per year, or 7,500 Y. So we'd write this as 175,000 plus 7,500 Y. To be at or above capacity, it must be greater than or equal to 325,000 tons. So 175,000 plus 7,500 Y would be greater than or equal to 325,000, or answer choice D. Let's keep going. Alright, question number 13. A researcher conducted a survey to determine whether people in a certain large town prefer watching sports on television to attending the sporting event itself. The researcher asked 117 people who visited a local restaurant on a Saturday, and 7 people refused to respond. Which of the following facts makes it the least likely that a reliable conclusion can be drawn about the sports watching preferences of all the people in the town? Let's see. Sample size is around 100 people, right? So that's decently large enough to minimize the margin of error. Population is just given as large, so outliers aren't going to do anything, right? So that will be a reliable conclusion. The number of people who refuse to respond to 7 is a small fraction of the total survey rate, so it won't really do anything, right? As if it would have a much bigger impact if, say, we had like 20 people, right? Like a fifth of the people total who did not respond, that would be able to sway something significant. But 7 out of 117, around 5, which is around 5 or 6% of the total, is not going to change that much. However, the survey is only being done at a local restaurant, which makes the selection of the respondents not random. Right? There could be a specific subset of people who prefer going to a restaurant, right? There's it may seem unlikely that that would skew anything, but you can justify it by thinking, like, say people who go to a local restaurant are more likely to go out to places, and people who watch sports on television are more likely to order something, right? You don't know, but that makes the selection of the respondents not random. That's all we need to really know. So that's why it invalidates the conclusions of the survey. So the thing that makes the conclusions the least reliable is where the survey was given, which is answer choice D. Right, let's move on. Question 14. We're given a graph by miles traveled by air passengers in country X for several different years. And we're told that according to the line of best fit in the scattered plot above, which of the following best approximates the year in which the number of miles traveled by air passengers in country X was estimated to be 550 billion. Well, here we can just take 550 billion, right, which is this line, which is this line right here, and we can follow it over here. It intersects right here between 2000 and 2005. The answer choice that matches up with this is 2003, answer choice C. Let's move on to the last question of this set. Right, we're told that the distance traveled by Earth in one orbit around the Sun is around 580 million miles. And Earth makes one complete orbit around the Sun in 1 year. And we're asked of the following, which is closest to the average speed of the Earth in miles per hour as it orbits the Sun. Let's see what we can do with this. Well, in a year there are 365 days, and each day has 24 hours. So in total you're going to get around 8,760 hours. Now 580 million miles divided by 8,760 hours is 66,210 miles per hour, which is closest to 66,000 miles per hour, or answer choice A. That'll be it for this set. Make sure to check in next time when we do the questions 16 to 20, but until then, I'll see you later.